Morning, fourth grade. Today we're going to continue learning about angles, but we're going to learn about how we can add angles or subtract angles to find either the larger angle or smaller angles that we don't know. So let me go ahead and share my screen and give you an example of what we're talking about today. All right, so on this page, this is not a page you have at home, but this is a page I pulled to give you some examples. We see in this first example that the angles EBC, and again that's EBC, and ABE, ABE, don't overlap, which means they don't take up the same space. So the measure of the right angle, A, B, and C, is equal to the sum of the measures of its part. And we already know, kids, that a right angle has how many degrees? Exactly, a right angle is exactly 90 degrees. Now we're only given part one of the degrees, EBC. The angle EBC is 30 degrees, but we do not know what ABE is. That's where the variable is. So we're going to use our knowledge of right angles, that all right angles measure 90 degrees, to determine what that missing angle is. So I have the total and one part. So that means I am going to have to subtract. Over here, it shows us the equation that you can write to create your math problem. N, which is the missing angle, plus 30 degrees, which is the angle we know, equals 90 degrees, which is what we know because this is a right angle. And we know that right angles equal 90 degrees. Then it says solve the equation. So in my head, I'm going to be thinking, what plus 30 equals 90? And I know that the inverse operation of addition is subtraction. So I can subtract 30 from 90 to get my answer. So they went ahead and did that for us. N equals 90 minus 30, and N equals 60. Because if we needed to go off to the side and do 90 and 30 up and down, we would end up getting 60. And now we can see that ABC is 90 degrees, ABE is 60 degrees, and EBC is 30 degrees. All right, so we're going to use all of that information that we know, and we're going to be using that to write equations just like they did here on the page, and then solve them for the missing angle. So let's go ahead and take a look at your practice page for today. All right, so at the very top, we see another example, and it shows us that ADC is decomposed, and remember kids, that just means broken apart into two non-overlapping angles, angle BDC and angle ADB. Now, it's a little hard on the photocopies to see all of the rays and the lines that make up these angles, so I'm going to go ahead and draw them with a red pen because it'll be a little bit easier to see. So there's ray DA, and then we have this ray down here, DC, and we have this ray here, DB. So now we can see this is the angles that we're talking about in this problem. So it says, this information tells us that the measurement of ADB is 90 degrees. So I'm going to find that angle on my diagram, ADB. And I'm going to go ahead and put a little box there because that's the symbol for a right angle. And we know that a right angle is 90 degrees, right? Very good. All right, then it tells us the measurement of BDC is 75 degrees. So BDC, this angle here is, I'm going to draw it up here, 75 degrees. Now it's asking us what the measurement of ADC is, and that's the whole thing, ADC. I see that it's a very big angle. It's almost a straight line, but not quite. So I know it's going to be pretty big. So now I know ADB is 90 degrees and BDC is 75 degrees. To get this entire big angle, we're going to just have to add them. We can add this angle and this angle to get the whole angle. So that's what they did here. 90 degrees plus 75 degrees equals 165 degrees. So angle ADC equals 165. Okay, so then they give you an example of subtraction. So we're going to use this same diagram and the same measurements, but they're giving you the example if they gave you the total and one part. So remember, when we have addition, we are given two parts and we need to find the whole. And when when we know we need to use subtraction, we're given the whole and one part, and we have to find the other part. All right, so in this example, it gives us the whole and one part. So let's read through it. ADC is decomposed. Again, kids, you know that means broken apart into two non-overlapping angles, meaning those angles don't share the same space. They are separate. ADB, angle ADB, and angle BDC. If the measure of angle ADC is 165 degrees, so that's our total, remember, because that's the big angle, and the measure of ADB is 90 degrees, that's one part, what is the measure of angle BDC? So now I'm giving the total and one part, which means I need to subtract. So I subtract the total. 165 degrees minus 90 degrees equals 75 degrees. So we were solving the same problem using the same diagram, just given different information. All right, so in today's lesson, you have something that looks just like this. You have a table to help you see the relationship between angles. And the one thing that might be a little confusing is that this table uses the same letters to name an angle, but the angles are not the same in each line. So what I'm going to do is I'm going to cover up every other angle. And I need to look at number one all on its own. I'm not going to be looking at anything else. So that's what I want you to do, kids. Make sure you are doing this one line at a time. And once you're finished with that line, cover it up and move to the next one. All right, and something that helps me, because I'm very visual, is to go ahead and draw it out. So I see angle TUW is 120 degrees. And angle WUV is 45 degrees. Now I'm going to go over here and double check and make sure I know which is the biggest angle. Okay, so it says angle TUW and angle WUV share a ray. Now I'm going to go ahead and draw a ray just anywhere on my paper. I know what a ray is. So I know these two angles share it, and I know the center point is that center letter is U. So I'm going to go ahead and put U here. And because they're sharing a ray, the only other letter that's the same is W. So I'm going to put a W up here. And together they form angle TUV. So I know, now this isn't going to be to scale, kids, but this is just going to help me understand how these angles look. TUV. All right, so now again, these aren't to scale. They're not going to be perfect, but I just need to be able to visualize what these angles might look like. Okay, so TUV is my big angle, and my two part angles are TUW and WUV. All right, so now I can see what it's asking me, and I can maybe write an equation to solve this problem. So angle TUW is a part, and angle WUV is a part, and what I'm looking for is the total. Angle TUV. That means I'm going to be adding. Remember, when we're given two parts and we need the whole, we're going to add. So on a separate sheet of paper, because I won't have enough space on this, I'm going to write 1. And I know that 120 degrees plus 45 degrees equals the missing number, which is angle TUV. Okay, so I'm going to go over here and I'm going to actually add them up and down because that makes it easier for me. 5 plus 0 is 5, 4 plus 2 is 6, 1 plus nothing is 1. So now I know n equals 165 degrees. So I know angle TUV is 165 degrees. All right, we're going to do one more just like that. I'm going to, just like I said, I'm going to move my sticky note. If you don't have a sticky note, that's fine. But I'm going to look just at this, and I'm going to cover that one up as well. Okay, remember, we are using the same letters for the angles, but we are not given the same degree measurement. So make sure you're looking at it one line at a time. Oh, and I covered up here. I need to double check. Okay, so that's TUW. So this first measurement, 105, is TUW. So that's here. I'm not given this other one. That's the missing one. And I'm given the whole one, TUV. So in this problem, I'm given the total and one part. So what operation am I going to use, adding or subtracting? If you said subtracting, you are correct. All right, so I'm going to go ahead and cover that one up so I don't get confused. And I'm going to come down here on my spare sheet of paper. Let's go to the other side. And I'm going to do number 2. So I have the total. So I'm going to start with that, 155 degrees minus 105 degrees, because I'm given a part, equals n, my unknown part. Because remember, we're given one part and the total, so it's subtraction. Again, I'm going to go over here to the side, and I'm going to subtract. N equals 50 degrees. So when I look at my, my total table, I see that TUW is 105, WUV, this one, is 50, and TUV is 155. All right, kids, so let's go ahead and take a look at the rest of this table. So I see automatically that we're given a whole and one part in number 3. So what are we going to do, add or subtract? Right, we're going to subtract. And in number 4, we're given a whole and one part. What does that tell us to do, add or subtract? Very good, subtract. And in number 5, we're given 2 parts and not the whole. So what are we going to do, add or subtract? Add, very good. All right, again, kids, if you need to draw it out, that might be helpful. If not, you can use those little notes. I'm not going to do the rest of them for you. You can solve them on your own. Okay, the second part of your work today, it has real life examples of different missing angles. And we're going to take a look, and we're going to have to use the information we know about straight angles and right angles to solve these problems. So if I look at this, it looks like a piece of stained glass. And this looks like the line or straight angle they're using. Now we are given two parts, but not the third part. And do we remember what a straight angle equals? If you said 180 degrees, you are correct. So I'm going to go ahead and write that down. A straight angle equals 180 degrees. So now we're going to use that knowledge. That is, the whole angle is 180, and we're given parts, but not all the parts. So we have 45, 45, and an unknown number. So use that information to solve number 6. Number 7, it looks like, yep, there's a little box there. What does that mean when we have a box in an angle? Right, it's a right angle, and right angles equal what degree? Very good, 90 degrees, perfect. All right, and number 8, we have again another straight angle, and we're given, that's broken into 3 parts. We're given 2 of the parts, but not the last part. So use that information about straight angles and their total degree measurement to solve this problem. All right, kids, I hope that really helped you. I know this week's lessons are a little hard to do on your own at home without getting to see a whiteboard and a teacher doing it. I hope you can meet us at our Zoom meetings today to help you with this lesson. And as always, reach out to Mrs. Fallon, Mrs. Donahue, or I if you have any questions. Have a great Thursday.